You are building a 508-meter skyscraper in one of the most earthquake-prone regions on Earth. The ground beneath you contains deep layers of soft sediment, and an active fault is nearby. Doesn't that sound insane? Taipei 101 answers that question in a surprisingly clever way. The engineers never tried to make the building completely motionless. They designed it to move, just never out of control. Most people know Taipei 101 because of the enormous golden ball suspended near the top. But the engineering that keeps this skyscraper standing begins far below anything a visitor can see. Construction began in 1999. The tower required 5 basement levels, extending more than 20 meters underground. But beneath the site were deep layers of relatively soft sediment. Putting an ordinary foundation beneath a skyscraper of this scale would create an enormous settlement problem. So the engineers went straight through it. Beneath the main tower are 380 massive foundation piles. Each is about 1.5 meters in diameter and roughly 60 to 81 meters long. Some extend as much as 30 meters into solid bedrock. Think of them as 380 enormous nails passing through the softer ground and biting deep into the rock below. A massive foundation system above them then distributes the weight of the tower across those piles. That solves one problem: stopping a 508-meter building from sinking. But earthquakes and typhoons create a completely different problem. They push sideways. Above ground, Taipei 101 uses 8 enormous supercolumns built from massive steel box sections filled with high-strength concrete. At the center are 16 steel box columns forming a heavily braced structural core. Outriggers and trusses connect the core to the giant columns around the perimeter. Imagine the entire tower as one enormous skeleton. When a lateral force hits the building, one column is not expected to survive it alone. The load is redistributed throughout the structural system. But there is still a problem. The taller a building becomes, the harder it is to prevent it from moving at all. Trying to make a 500-meter tower infinitely rigid is not necessarily the smartest solution. So the engineers took a different approach. If the tower is going to move anyway, control the movement. That is where the famous golden sphere between floors 87 and 92 comes in. Its technical name is a tomb mass damper. The sphere is approximately 5.5 meters in diameter and is constructed from 41 layers of solid steel plates, each about 12.5 centimeters thick. Together, they weigh 660 metric tons. Hundreds of tons of steel are literally suspended high inside the skyscraper. So how does that help? When wind pushes the building in one direction, the massive suspended weight cannot instantly follow the building because of inertia. Relative to the tower, it moves out of phase with the structure. The building sways one way while the damper produces an opposing motion. Large hydraulic viscous dampers beneath the mass then dissipate part of that motion's energy. The genius of the system is not that it prevents Taipei 101 from moving. It uses motion to fight motion. But one of the tower's most dramatic tests happened before construction was even finished. On March 31, 2002, a magnitude 6.8 earthquake struck Taiwan. Taipei 101 had reached only around the 56th floor. The shaking brought down 2 construction cranes and tragically killed 5 workers. Everyone wanted to know whether the unfinished skyscraper itself had suffered serious structural damage. Inspections found no structural damage to the main tower, and construction later resumed. But this is where many retellings of the story get something important wrong. The golden tomb mass damper did not save Taipei 101 during that earthquake. It couldn't have. The damper is located between floors 87 and 92. At the time, the tower had only reached about floor 56. The famous sphere had not even been installed. What the earthquake actually tested was the foundation, structural frame, core and seismic design beneath it. The 660 metric ton damper came later as another layer in the tower's motion control system. And that is what makes Taipei 101 so interesting. There is no single magical component keeping it alive. Hundreds of deep piles transfer its enormous weight into the ground. Its supercolumns and a heavily braced core resist the forces acting on the tar. Outriggers spread those forces through the structure. And high above them, the giant tomb mass damper helps control unwanted motion. Taipei 101 survives not because engineers simply made everything as rigid as possible. They decided where the structure needed strength, where it needed flexibility, and where energy needed to be dissipated. Good earthquake engineering is not about challenging an earthquake to see which one is stronger. It is about making sure that when enormous forces enter a structure, no single component has to take the entire punishment alone. So here's the question. If you were living 500 meters above the ground, would you trust a skyscraper design never to move? Or one designed to move, but always stay under control? Tell me what you think in the comments.